Hello, it's Michael from Archimede Design, and welcome back for those who've been to the channel before, and welcome any new subscribers or viewers of my videos. So, a while back we did a video on how to do parametric modeling in Fusion 360 using parameters, and I did a simple grommet. That gave me this idea of doing a kind of unique grommet or some sort of design that I might want to make out of silicone and mold it. So what we're going to do today is we're going to make kind of a grommet slash footing type design that's going to be made out of a regular dodecahedron. So you'll kind of see how to make a dodecahedron in Fusion, and then what we'll do is we'll actually make a molding tool model within Fusion 360. And then one of the next videos, or maybe part of this video, we'll determine how that goes. We'll 3D print that and then do an actual mold out of silicone with that. So let's get started. All right, a couple of things we need to do first is open Fusion. I already have mine launched. And then we need to kind of just look at what the geometry of a dodecahedron looks like. Have browser open here. And this is a regular dodecahedron, so it's a pentagon with 12 sides. Many of you have seen this 12-sided dice, right? So I want to make this, and I want to cut this in half and make it as a footing that could be on the top of some sort of 3D printed enclosure or something of that like. So the big thing to note on this thing is really what's going to be important is the inside angle between two of these faces. And I'm on Wikipedia. You can find this information, but it says 116.565 degrees. So we're just going to want to remember that and write that down. So how do you make this? There's actually a few videos out there on how to do this in Fusion on YouTube, but we'll just quickly make it and you get a feel for it. It's really, really easy just to do it using surfaces. The first thing is we're just going to create a pentagon on that flat XY plane. I want to do an inscribe here. I want everything to be based on the outside diameter, so I'm going to put it right at the middle. Right now it's 6-sided. I need to change that to 5-sided. And I am going to pick a size here in a little bit, but let's just randomly pick for now. And let's just set this dimension right here for now. And we want this to be horizontal, vertical, and that will define our pentagon. So in the past, I highly recommended that we try to start using parameters. So we are going to add some parameters for this project. We'll start there. So I'm going to make this pent die divided by 2. All right, so we can finish that sketch. So here we have our sketch on this plane, and I want to create a construction plane. At an angle along, doesn't really matter which line, so let's do it along this line, and you remember, we have this angle of 116, and now let's create a pentagon on that surface. Got to change that to 5. Let's make these 2 points coincident. Finish. All right, so now you have this. Maybe you can see where I'm going with this. The next thing is before we kind of finish this, we want to make these into surfaces. So we're going to create a surface by selecting the patch. Create another surface, create a patch. Now we have 2 surfaces. And now what we're going to do is we're just going to rotate this around 5 times, well, 4 more times, the center line of here. So turn that origin on, modify, or sorry, let's do rotate pattern, circular pattern. The object is here, the axis is here. And we want 5. And there we go. Now we want to have 1/2 side of that dodecahedron. Right, so now what we want to do is we want to take this and we want to rotate it and copy it. Okay. And let's then get these to go, move this from point to point. There we have a dodecahedron right now that is 2 sides. And we're going to stitch these 2 sides together. So we'll just stitch these 2 bodies. And by stitching those 2, we've now created a solid model. All right, so my plan here is I want kind of sort of half of this to be like the bottom footing of some sort of footing you might put inside of a enclosure of some sort. And so I want to split this body across one of these. You know, I could split it right down the middle. I could split it in at one of these higher points or lower points. But since we're going to make a mold out of this, I kind of want to make it a little complicated. So let's split it on the top edge right here. So what we're going to do is we're going to create another construction line through 3 points. We'll do those 3 points. And let's split the body with that plane. And now we should have 2 different bodies. This body we don't really need. You can delete it, or let's just remove it from the model. So here we have kind of beginnings of what I'm thinking about. So since I'm going to have this as a footing, I do want to have a hole that goes through here. That was the 4.5 millimeter hole. So let's start with that. Let's do a couple things. I want to get creative here. Let's create a new drawing on this surface, new sketch, and let's create a little insert here. Let's call this wall thickness. And let's extrude that inward. I don't really have a value for this, so let's just do it times 2. And let's put a little bit of a taper angle on that. Now, the reason why I want a taper angle possibly is because it'll help with any kind of releasing of a mold. You know, when we do the mold, it's not probably going to mold this way per se, but we'll see how it all works out. Let's just actually make that 1.5. So technically you could stop right here with a 4mm screw. But I wanted to also make this so it acted like a grommet previously, where we had a push-through portion here that kind of could lock it in place. So let's add to this that type of feature on the top here. There we go. So now if we want, we can just put some radiuses on here. And we could do our inside radiuses. Okay. So there you have it. Make it out of some sort of material. Silicon nitride. We'll give it a color. Let's just give it a color. Now let's just make it red. Let's save that. So there we have a pretty basic half regular dodecahedron footing with the push-through grommet end on it. So next thing will be how do we make a tool out of this so we can actually maybe mold this out of silicone? Now, yes, if you have access to a 3D printer that can print TPU, you could just print it out of TPU. It would be fine. But if you want to have some really nice smooth edges, or if you need to make a lot of them, you can use these types of techniques to make more, especially if you want to do unique colors or dyes or different types of materials. So that's what we'll do next. So, all right, so how would you go about doing a mold for this? If we're going to do a mold for this, we have to then make a cavity. So in a sense, this becomes our tool. We're going to use this to subtract this cavity out from a solid model. A couple things to keep in mind, though, when thinking about this. When you have overhangs like this, you have to think about taking into account how this is going to pull apart. So for us, we have an overhang here. There's lots of different ways you can go about it. We can have inserts coming around the outside to make this ring. But we also have a hole through the middle and on the back of this. So we also have to take into account is how do we make that recess? And then thinking about, wherever you have a seam, that seam is going to show up. And are you going to be okay with that seam? So one way we might think about this is that, yeah, we would have inserts come in where this neck is to make that neck, and that would create seams at these two surfaces. So they'd kind of be hidden. And then from there, we could pull another insert from the bottom that creates this shape. However, when you do that and we mold this thing, there's a little bit of overhang coming over on here and over on here on these sharper angles. So yeah, it's silicone. Maybe you could get it out of the mold with a little bit of effort. So that kind of creates a problem too. So there's lots of different ways that you need to approach this so you can get your part out. But if we actually look at the top, the best place to probably do this is going to be across this surface right here, straight across. So we'll actually make a part that pulls apart from those two parts, and then we can do an insert on the bottom for that polygon hole and that through hole. So those two parts pulling apart will also create this shape as well. We will get a seam out here on this one side of this edge, but I'm willing to live with that. I want to make this easy to mold without it being too complicated. So where do we start with that? First and foremost, we just need to create a solid around this that we can subtract it from. It can be a little discerning here because we don't really know. It's hard to tell what size this is. We made the outscribed diameter here 1.125 inches. So if I kind of zoom out and see what that roughly is, it's pretty small. That's a small part. So if you try to just make a little mold cavity out here, it could be tough to handle and really work with. So I really recommend making it at least 2 inches square all the way around, so you have some body to work with, so you can clamp it or whatever we need to do to make sure we can put silicone inside of it. So let's just do a new offset plane, and let's do it from here. Let's do a new sketch. Bottom. We're going to do a center rectangle. And what did I say? 2 by 2. All right, so 2 by 2. So looking at this thing's actually larger than I thought it was. And that's I guess not thinking about that. The dodecahedron it's this surface here that is 1.125. So 2 by 2. So this is actually pretty sizable. It's probably too big. So let's modify our design a little bit before we even jump into this. So I'm going to just leave that 2 by 2 there and finish my sketch. Go to parameters. change parameters. So our pentagon diameter is 1.125, and right now it's about 2. I really only want this thing to be about 1.25 inches. So let's try making this 0.6125. Look at that. Wow, that quickly just made a change, didn't it? We did lose the definition on one of our radiuses, which we can fix. And this is a little bit bigger than I thought it would be. So let's go in and just change that sketch. All right. Now let's look at this on the bottom. So here we have a good amount of space around the whole thing. And, 2 inches is I don't know. To me, I think it's a little small still too. So let's make it 2.5. I've done these before, and if you get too small, it's just kind of hard to handle. Okay. And let's extrude that 0.5 as well. New component. We're going to do a new component here. Let's we'll rename it in a second. Let's rename that mold tool for now, mold tool 1, because we will be breaking this up as well. So if we hover over this, just so it highlights, you can see we have this inside there. It's not quite in the middle, so we can move that down just a little bit. We'll just First thing that we want to do is, I talked about us having a piece that will pull from the bottom that's creating that hexagon and through hole, and then it'll get itself split in half. So first we need to kind of define those pieces. So first thing we're going to do is just subtract our body from this solid. Split body. We're going to body to split is going to be this one. Our tool is body 9. I should rename that. And we're just going to do OK. Let's rename this body as flipping Grommet. Okay, and we can just hide that. And now I'm going to turn over to the mold tool being my active component. And let's also do an inspection here of section analysis. And we can do, doesn't really matter because it's symmetrical, right? Let's do XZ. So what we have here now is we have in my mold tool 2 bodies that were created from using that tool. The one that is on the inside, I don't need anymore. That's to be a cavity, so we can just remove this. You can delete it, but I like to just remove it. So now we have this cavity. Of course, no way to get anything in this cavity, no way to take it apart. All right, so now we need to cut this. And looking at it, since we have this radius right here, if we want to maintain that, we really need to try to cut it at that line and across this plane. So now I have these two planes. So let's cut here and here, and that's going to give us basically a few different new bodies. And then I'm going to merge this one and this one into a single body. So I have that, now that, and this middle piece. So what I'm going to do now is I'm going to merge these two top ones. So here we have a bottom insert that has that shape of that hexagon hole and then the through hole. If I turn this on, you see we have a hole here into a cavity that right now really can't get to. So let's get back to what we wanted to do there. I'm going to bring back my body of my grommet footing. And we talked about the best way to maybe cut this would be like straight across where it's these two widest points. So if we look at our origin, it's pretty much along that plane. So let's do that plane. And now this time, I only want to cut body 3. What I'm going to do with body 2 is I'm going to make body 2 its own component. Let's turn that off. Now we're going to go back to this one, and we're just going to call this the mold tool. Let's rename body 3. Doesn't really matter because it's kind of symmetrical. Let's just call this cavity right. Now we want to split cavity right. There. So if we look at this, turn off our origin, turn off our construction plane. So here we do is we have our cavity. And if we look at cavity left, it's the opposite. So with that, it doesn't look like we have any overhangs or anything. So these two parts will fit together, and then the bottom will come in, and then you fill with silicone, and then you pull the bottom apart, pull the other two apart. Let's just save this. All right, so the next thing we need to do is we need to put some registration marks into this, our locations. So we want to put some holes and pins and things like that to help align the tool together so when it fits together, as well as holes for putting some fasteners through to tighten it all together. We need to kind of clamp it together. You can use clamps, but I tend to just use some threaded bolts and nuts, and then just get it all clamped together well. And then we also need to put holes in to shoot in the actual silicone. So let's start with those first. Let's do the holes for the silicone. So you want these to be a decent size. I'm going to make them 1/10 of an inch, and I'm going to want to try to keep them away from the edge of the curve here just so they're easy to cut off, but it isn't necessary. And you want to, let's try to avoid having it lock on any particular spot right off the bat. So in this case, I want this hole to go through both parts, so I'm going to show both cavities. All right, so you're probably asking, why is that there? So I might not do it in my example just because I might not have access to it, but you can put these molds inside a pressure vessel. Some people actually use a vacuum. I like to use a pressure vessel for silicone. And what it does is that squeezes all the bubbles down and gets them out. And a vacuum container does the same thing. It gets all the bubbles out. But vacuum containers have difficulty sometimes getting bubbles out of silicone around certain flat corners, but I find pressure works really well. But when you do use pressure, it's possible that you will get a little bit more silicone that gets compressed. So it's nice to create a little reservoir with additional silicone so that if it does compress that all in, you have a little excess. So now we have a way to inject the silicone. The next is we're going to need some holes to go through to clamp this down. We need to clamp it both down this direction and then also through that direction. Could put 4 here or, well, just 2 here. I think that's what we have room for. We can put 4 as well, but we're going to do a new sketch on the top again. Now in this case, these 4 holes have to go through even the hole insert. I spelled it wrong. So let's include that as an active component too. So now we're going to go all the way up to the top component, select it. I want to make sure everything is visible. All right, so now I want to go through this direction to connect these two. And we got to be cautious because if we take away one of our cavities, we don't want to run into our cavity. And we also don't want to run into these holes. So let's actually do drawing off of this surface. All right, pretty good. We're moving along. So here we have all of our through holes that we can put in through some fasteners to get it all clamped together. That way when we put our silicone, it doesn't completely squeeze out. It will squeeze out a little bit. Keep that in mind. It's viscous enough though where, again, why you might need a little bit of reservoir in case some does bleed out. So the next thing is we need registration marks. We want to make sure this thing lines up correctly. We need like a pin in a socket, pin in a hole. So we got to start looking at those things. So let's go and get rid of our hole insert and say we want to line this up. And you can see that as the pentagon, so it's only going to fit in one way there, but we got to make sure that it leaves the adequate room around the thickness of that part. So we can put, let's say, a pin here, but then let's put one offset a little bit over here, and that way it only fits together one way. Okay. Now let's still want to see this sketch. So I'm going to use this sketch. So now, since I made holes into those, I'm going to do a new sketch here, top, and the same location as those holes, but this time 0.25. You can see it's a little bit smaller. It's a wee bit smaller. And even when we're done with this, we actually may have to drill the holes out a little bit, just to make them nice and clean. But generally, you just want to make them a little bit smaller. All right, next is we need to do registrations between pin points. For these two. So let's just turn one off. It's the same approach. This though is they're symmetrical to each other, so it doesn't really matter where if we offset them or make them in a weird spot. So we'll just do a couple in the two corners here. All right, so that's everything. Let's turn off our analysis. So there you have it. There's a mold right there. Save this. So there you have it. Making a mold for a half of a regular dodecahedron footing grommet, whatever it is. So the next step with this is how do you 3D print this? How do you treat that? And then using silicone, we'll make some of these things. So that'll kind of be the next video. Keeping in mind that you could do this for multiple cavities. The more complicated, obviously, the more difficult it is and more time it takes to make the solid model. But you just follow pretty much these same types of steps. If you have any questions, list them below. Don't forget to subscribe and like my video, and hope you'll return for when we actually do the 3D print of the mold and silicone injection. So thanks again, and see you next time.